As part of the Insight Maker overview series, I'd like to spend a few minutes talking about the options on the Tools menu. Tools menu is not very long, though it has some really nifty features on it that I continue to find very useful. The first one is the scratch pad. Notice if you click on it, it does this check. And what it does is it puts this utility here on the left-hand side, which is the same utility that was presented as part of the graph pad display. You can select an item, and then you can draw annotations on your diagram, or you can undo them, or you can select areas and erase them by selecting over it. And whatever you draw stays there until such time as you reload the Insight. So if I come up here and I click and I turn it off, it's not there. If I click and turn it back on, it's still there until such time as I reload this Insight. I find this really helpful sometimes doing presentations when I want to point out things and make them temporarily known so that you can do this. It works much better with a pen tablet than it does with a mouse, but it's usable to some extent. The second option is identify loops. It's a utility that will go through your model and identify all of the loops that are created in the relationships and sequence them for you. And if you happen to code your connections, your links, consistently in terms of one color for adds to or increases or the same direction, and the other as subtracts from or an opposite direction, you can determine whether or not it's a reinforcing or a balancing loop simply by counting the number of subtracts from opposite relationships. In this particular model, it doesn't work too well because there's a couple of flows in here that are bidirectional so that they show up as gray rather than a color, meaning that in one instance this ends up being a balancing loop, in one instance it ends up being a reinforcing loop. And that those pretty much, well, here's a clean one, capability actual performance gap. All right, it's got two, oh no, it does have one in there. So but if you're doing just relationship maps, causal loop diagrams, it is really helpful. So that once it points the loops out to you, you can make sure that you have labeled them in your diagram. The third one is compare results. This particular simulation model provides implications of a set of relationships that develop based upon whether an organization faced with a required performance increase decides to spend its time working harder or working smarter. So if we run this simulation with this hard smart parameter at 20.25, meaning they spend 75% of their time working harder and 25% working smarter, we get this output. If we then decide to see what happens if they spend 75% of their time working smarter and only 25% working harder, and run the simulation, we get a markedly different output, though to compare the two of them is a little difficult because you can't see them actually side by side. So if you use the compare results option, you can tell it that I want to compare results 5 and results 6, and I want to compare the cost of operation and the time spent working. It then creates me a new output which shows me simulation 5 in green and simulation 6 in blue. So it shows this is what happens to the cost of operation if I focus on working harder, and this is what happens to the cost of operation if I end up working smarter. And in terms of the time spent working, if I work harder, well, I spend more time working harder than if I work smarter, and it actually ends up decreasing the amount of time after an initial increase. So if you run any two given simulations that you have the displays on the screen, you can compare them so that you could do this for You could make a 0.5 and run another simulation, and you could decide to compare any two of these, because now there's actually three of them here. Well, I could actually decide to compare all three of them. So now it'll give me a comparison of all three of those runs. So pretty useful feature in terms of being able to see and compare the results from different sets of parameters. The next option is a sensitivity testing. Given this very simple rabbit birth model, where given a rabbit birth rate and some initial number of rabbits, the births add to the rabbits and the population of rabbits grow. And the birth rate is 10% plus times a random number from 0.5 to 1.5. So that each time you run this, the output is slightly different based upon the random number that gets generated. Though, to get a sense of what the results are likely to be overall, you can do sensitivity testing and say, I want to monitor rabbits, I want to run this model 50 times, and I want to display the confidence regions for 50%, 75, and 100. So when I run this analysis, it's now run the model 50 times, and it shows me that in the yellow, there's a 50% likelihood that the answer is there, 75% likelihood that it's in the blue, and 100% likelihood that it's in the brown region, so that you can get a sense of the extent to which the behavior of a model is dependent upon one or more individual elements someplace in the model itself. Okay. The next option is a optimization option. Here's another version of the rabbit population model with a given birth rate of 0.2 and an initial number of rabbits of 200. And if you run this model over a period of 20 years, the blue line represents the actual measured number of rabbits. So the population predicted by the model is not very close to the value measured actually. And what you'd like to do is you'd like to adjust this rabbit birth rate so that the model more accurately predicts the measured results. So what you can do is you can run the optimization feature and tell it that this prediction error, which is the square of the difference between the population from the model and the population measured, and you want to minimize that error, and the primitive to adjust is the rabbit birth rate. So you run the optimization, and it tells you that the optimum value of that parameter is 0.234375 as opposed to 0.2, which it was. And it also went ahead and actually changed that parameter. So if you now run the simulation, you notice that it's not perfect, but the simulation presents a closer approximation to what was actually measured over time. So now the last option is macros and variables. Oftentimes there's a very large set of functions that are predefined in Insight Maker that you can use in equations when you develop them. I mean, not random number functions. There's just a bunch of them already defined. But you end up with situations where you have functions that you want to use, and you want to use them in multiple places in the model, and it just gets annoying trying to code it and copy it and put it in multiple places. So the macros and variables option allows you to create definitions for variables or functions. Here the example is you could input the value of gravity 9.8 whatever meters per second squared, or the temperature conversion from centigrade to Fahrenheit. In this one, I just defined a function called minus xy, which is x minus y. What I did was I used that function here to say minus the full minus the bathtub, so it runs just as though I coded full minus bathtub in this location. So if I look at bathtub 2, I mean, it's so you can use that feature to define whatever, where is it, functions you might need in the model, and they can be extremely complex if need be. They can be multivariable and multi-line functions. So some very, very interesting, useful functions in the tools menu. So as I said, this is part of the tools element of the Insight Maker overview module in Systems KeLE, and there's a link to this module in the notes section for this video. And I'll see you in another video soon.